Does anyone have, here we go, any questions on anything? I tended to share screen. There we go. So
are we gonna do together 5.2 worksheet 2?
let's do it. Is that what you would like to start with?
I already did it, and I just want to make sure that I did it right.
Love it. Well, let's start there. How many people, come on, there we go. How many people have done it?
What worksheet are you talking about, Eric?
5.2, number 2. This one. Okay, that's okay. No worries. Maybe we should start with our overview. Did we do an overview of 5.1?
I don't think so.
All right, so let's do that. Let's do our, there's the nice thing about chapter 5 is there's not lots of overviews to do. It's a pretty, there's not tons of concepts in here. They're kind of maybe new, but they're not like a million concepts like 3.1 or 3.2. So let's, there we go, we're drawing. So let's start there. 5, hello, there we are, 5.1. So here we got a bunch of stuff that you all seem to like. This idea of what is probability. And mostly the thing that we wanted you to keep track of with probability is its numerical representations, kind of as the, or maybe a foundational thing. So, right, we use the word impossible, equally likely, and certain, or it's going to happen or whatever. And we could write these as decimals, percents, or fractions, as provided those numbers fell between 0 and 1. Outside of that, there's no meaning to them. And so then from here, we said, oh, this is a numerical measurement of a chance, or it's a, you can think about predicting the future, sort of. And we define this idea of a probability experiment. And this is something that has well-defined outcomes that we could repeat over and over and over. And that kind of thing is, we could, I don't know, we could debate how many problems we've looked at really meet this definition, but they all roughly meet it. Like you can think of a student attending Jackson College as a probability experiment. And we could look at all the students that come to this college and decide how many classes of statistics do we need to teach based on our data set of prior students. So students from last year, we use it to predict the next year, or we look at the high schools and we try to predict our enrollment. Those are all kind of probability experiments and models. Okay, so under the idea of a probability, we had 3 types. We had the classical, which is based on theory. Examples are any game of chance, playing cards, any of the gambling games where you know all of the outcomes from the get-go. And so theoretically, a coin, a fair coin, will land on heads 50% of the time. But practically, empirically, it may not look like that. And that's where the law of large numbers came in. And if you flipped a coin infinitely, it would match the theory exactly. So empirical is where we take a data set, like I was talking about for the probability experiment of guessing the number of students that will need a statistics class for our spring semester. We look at data and we use that to construct probability. One of the things that hopefully you made the connection here, I think we did it in the 5.1 worksheet, is that back in chapters 2 and 3, we did some talk of relative frequency, and from I forget the name, the distribution. We now are calling this probability. They're the same thing. And that is connected to that empirical probability. And then, of course, there's the subjective, the not as interesting one. This is an educated guess. I think sportscasters. Some calculations or notation and calculations. We had probability of an event occurring is equal to the number of outcomes in the event. And E divided by the sample space. I'll just put quote marks and say sample space. So you had to do a couple things here. One of the important things was to write the sample space. And that's all possible outcomes of a probability experiment. So you need to be able to write that. Remember, we used a tree diagram to help us. And the other thing we used was the multiplication rule. This was to figure out the sample space size. And that's about it from 5.1. Anything I'm missing? Oh, yes. How do we know if it's a valid probability model? And there was those 2 criteria. This should go in your reference sheet because I don't think it's anywhere. That is, each individual probability in the model, so in the table is often how we show this, has to be a number between 0 and 1, and it can equal 0 or 1. And then the sum of all the probabilities has to add up to 1 for our model to be a valid model. So then 5.2, we just added 2 new concepts, really, and maybe 3. And that is, what's the idea of a disjoint outcome? So if you think back in what was happening in 5.1, here we're laying the groundwork for all the stuff. We're giving you the language to talk about probability problems. So we're defining the numbers it can be and how they can be represented. We talk about what this experiment is and the types of calculations we can do, a theoretical or a data or a guess. Here's the way we do those calculations. And then we talk about the sample space. I should have put this in here. It's the collection of all outcomes. And the outcome is something that can happen, a predictable thing. Drawing a card, an outcome is whatever possible card numbers there are, that kind of stuff. So now we're saying, oh, not outcomes, I'm sorry. Now we're saying when we define an event that is occurring, we could have disjoint events, meaning there's no common outcomes, or we could have not disjoint events that have common outcomes. So there's not a special name for it. And it can be one of the two. It's either disjoint or it's not disjoint. There's no other options. So we have some sort of experiment and that has its sample space. And then we define an event in that experiment and define another event. And if they don't share outcomes, then they're disjoint. And from there, we get the way to calculate the probability that 2 disjoint events occur. Probably the event E or F, and that's the sum of the 2 probabilities, provided they're disjoint. If they're not disjoint, then we have to subtract that overlap. So there's really only one formula. So what we say here is if disjoint, this piece equals 0 because there's nothing in common. If it's not disjoint, then you have to count up how many things were in both E and F and subtract those away. And then the last thing that came from here is the complement of an event. And that's directly related to disjoint events because complements, events and their complements are disjoint. So there was like 3 representations, EC, E prime, or E bar. The most common word we associate with complement is the word not. It's not in there. And that sounds like a word that people used to say back in the 90s, right? That were cool. And maybe now they're not cool when they say that. Or was it the 2000s? Maybe I was in high school. Real sarcastic not, you all know what I'm talking about. Maybe I'm just crazy. So the way this looks is we have a little formula like that. And I think it's important to note that E complement and E are disjoint events. Turns out that this disjoint thing is super useful for some calculations. Okay, so that's roughly what you know. Any comments on any of this? Does that seem crazy? Yeah, it does, because what's up with what I said here? Should say no common outcomes. So let's try this stuff, all right? So we're going to start with the worksheet for Cindy, which is this one. Correct me if I'm wrong. So we'll say here, Cindy, this is, in other words, 033. And I believe this is due 10/9 is the idea. So how about, oh, I don't have my phone. How about we set a timer for?
Hang on, did I miss where we went over the 5.1 all the worksheets we've already done? I couldn't have, I've only been here 13 minutes.
No.
Oh, are you going over these
Are you
later?
talking about, are you talking about this?
511, 512, and 513, and 523. Those are all worksheets that are done.
Good. Do we need to talk about them?
I would love to.
Okay.
I mean, I'd love to make sure I'm doing everything right before we move forward to something new.
So which one did you not know? Which one should we look at first?
Actually, Eric, I think I did them all right. So
okay, well, good.
I know, but that's not everybody, and I don't know if I did. So the thing that trips me up, I think, is that tree thing, the tree diagram, where I don't know if I have the right branches, but
Gotcha.
I mean, that kind of screwed me up a little, but it seems to me like that was a very small part of what we were doing.
We did.
Okay, 5.1 worksheet 2, I think we already went over this one.
Yes. We did 5.1 worksheet 2.
Okay.
Yes.
So this one is in the videos.
We did start 5.1 worksheet 3 as well.
5.1 worksheet 2 is done. Okay, I'm just gonna put these away.
I think
5.1 worksheet 1 is done, right? Did we do that one already?
We don't. That one we threw out.
5.1 worksheet 1 we threw out.
Yes.
After I did it,
that's not on your assignment sheet.
Sure it is, because I turned it in.
Good.
This is really frustrating, you guys. Okay, 5.1 worksheet number 3.
Now we did this in the videos.
Yes.
On Wednesday.
That was in the videos on Wednesday.
We did all of this, all of this, all of this. I don't know we did number 6.
5.1 worksheet 3. Okay, 5.2 worksheet 3.
We haven't started.
Right,
that's what we're doing tonight. Today. Yeah, that's where we're starting. But we're going to start on number 2.
All right, I don't have it printed out, so I'll just do it online. Thanks.
Cool.
You guys are throwing out stuff after it's done. Anyway, here I am. No, it's just frustrating. You guys know how long those worksheets take.
Yes.
And so I spent, so much time on it. And if there's a place to turn it in, how could it not be an assignment? So that's all I'm saying.
It was on Eric's thing, but it was not on the assignment sheet that I sent you.
Well,
Yeah,
how about
I
we
hear
get
you,
them so
Peg.
they're all consistent?
I
Just
need to
say,
match up Canvas
please.
to the announcements that Cindy sends out. Yes. Yep. I agree with you. That's a very valid critique of me. Okay, so
What page is this worksheet on?
this is page 552. So let me give you, let's take 5 minutes for you to contemplate what's happening here for those of you who haven't started, and see if you can't get started, can't figure out where it's going, and then we can talk about if you're stuck, and if you need more time, we can take more time. Just let me highlight a few things to keep track of. The big thing in 5.2 is this word. That is the big thing to keep track of. And what goes with that word, well, this is also the other new thing, this little C thing. What goes with that word is the concept of disjointness that we just wrote down. And so what you're trying to decide in this worksheet is, are things disjoint? And if they are, you can just add up the individual probabilities just like we did in 5.1. If they're not disjoint, then you have to subtract the extra. All right, so let's do that 5 minutes. Come on. And we will go from there. Oh, there we go. Okay, that was 5 minutes. Did you note, can someone, before you answer anything, can someone tell me what this experiment actually is? What is this probability experiment? What are we doing in this experiment?
Which one? Number A?
Number one, not even the questions, but just number one, what is the experiment?
You're spinning the arrow once.
Nailed it. Excellent, Peg. This is a key point. In 5.3, how we're going to complicate this problem is we're going to spin it more than once. So Taylor, excellent. What you've told us, which is a really good thing to note, is the sample space. So often the way we write sample space is S, and then this thing, and we've got three things: blue, red, yellow, green. Are they equally likely to occur?
Yes.
Yeah, because they're the same area. Excellent. Okay, so what are the chances that our arrow lands on red or blue?
Once for each.
Once for each. Excellent. If we were to write this in symbolic notation, first we would note, it would look like this. We would note their disjoint. It would not look like that, unless we pretend that blue equals G. And we would write it like this. Now, please understand, you do not have to do all this extra work to write this out. I just want you to see symbolically, this is how we would do it. And then we'd say 1 out of 4 plus 1 out of 4, which is 2 out of 4, or 1/2. Okay, that's all way too much. All you need here is 1/2. But I want you to see kind of how that's put together, the structure of it. What did y'all do for B?
So anytime it says or, that means we're adding all of them together.
Oh, B.
Unless, that's a really good point, unless they are not disjoint. So I guess we should have paused and said, are these disjoint? Can you land on red and green at the same time?
No.
Good. So yeah, this is just 1/4 plus 1/4 plus 1/4, or you could think, look, there's one blue, one green, and one red. So there's 3 ways that one of these 3 events could occur out of the 4 possible options. Good. Now, if you prefer, we can use that rule that we wrote down. Oh, hang on, let me change my sharing. Oops. Okay, I should just use my mouse. Here we go. We could use the rule that we wrote down here. And this is the rule that I'm showing, this piece. Because this part in the disjoint stuff is all equal to 0, so we don't need it right now. It's going to change in a second, of course. Okay, so we could write this down as the probability of red plus the probability of green plus the probability of blue, and that's equal to 1/4 plus 1/4 plus 1/4, because that's the chance each one of those happened, and then that's equal to 3/4. Okay, do you know what this is talking about?
The complement, which is, are you talking about C?
Yeah, C, yeah.
The complement, which is everything that's not green.
You got it. So it says what outcomes make up that. So we just are supposed to write those down. That would be blue, which isn't green, red, which isn't green, and yellow, which isn't green.
Would
Excellent.
that be marked incorrect if we did not put it in the little brackets that you just put? If I just put red, yellow, blue?
That's fine.
Okay.
Also, about those brackets, what if you use parentheses on accident?
That's fine too. When we get into interval notation and confidence intervals, they do mean different things, which it's kind okay, baby, just a second. which is, it's good to think through it. It's just notation, and I'm not going to be super picky on this. This is a way to say there's a collection of things inside here. We're just writing a list. Whereas this says, think about everything between 0 and 1. So things that could go inside here are like 0.5 or 3/4. So that's the difference between the notation. But again, I'm not going to be super picky. I think it's helpful to keep track of those in your mind because they do have meaning. But yeah, I won't be picky. Okay, so what is the probability of green complement? Just a second, Peanut. Just a second, okay.
3 out of 4.
Nailed it. Same thing as above, as the one above, right? This problem is very, it's a much simpler problem. It's one, okay, just a second. But they don't really get much crazier in this. All right, this one's tricky though. What do y'all think about number 2? If an event is certain to happen. So
I put the complement is an event that will never happen.
Nailed it. Yes. Has to be that. Now we can show that kind of algebraically, if you will. If you look back at the formula I wrote, the probability of E complement is 1 minus the probability of E. So if this is event E, and we use that little formula I wrote down, then the probability of E complement is 1 minus the probability of the event, which is 1 minus 1, which is 0. If that's nicer for you all, then you can think of it that way. Excellent. Okay, let me give you a few minutes to, what type of probability is this, probability experiment is this? Classical, empirical, or subjective?
Is it classical?
How did you know?
I guessed.
That's a good guess. Why did you guess that?
I don't know. It just seemed like really basic, so.
So here's the way to distinguish. Oh, go ahead.
Because you know all the outcomes.
Yeah.
You can see all the data.
Yeah, we're basing it on this theory, right? It's a spinner, there's 4 things. Did we do any spinning?
1 time.
Well, I'm even being more basic than that. Did you literally flick the thing and make it spin?
No.
Yeah, no, we're just like, if we were to do this, this is what would possibly happen. Now, if we went and we all bought spinners and we started flicking them and keeping track of what happened and created a table like this, then we'd be working with an empirical probability. So this one's classical. This one is empirical because it's a data set. Your intuition was really good. I don't have my speaker thing set. So whoever said that, who said classical first? Good job for you, whoever you were. Okay, so let me give you 5 minutes to work on this. Do you all know what to do with this column probability?
It's just like the relative frequency. Add up the frequency and find out what the whole sum is, and then you divide the number 8 into that total and do 3 decimal places.
You got it. Okay, I'll give you 5 minutes to try this and answer these questions. Notice we're selecting a week at random. So we're selecting one item and you're going to calculate these 3. So 5 minutes while I get my kind of sick daughter a popsicle. It's a fruit smoothie popsicle, so it's super healthy. So no judgment. How are we doing? Is everyone? I feel like 5 minutes might have been too much time, but is it not? 29. Okay, that was 5 minutes. Did you all get the same probabilities I did for the table? That's the first part.
I got the same.
Nice. Because if we have different things here, then all of our answers are going to be different over here. I'm going to write out the symbolic parts of these. By the way, note that what this 29 represents is the number of weeks that this car salesperson is analyzing. So there's a total of 29 weeks worth of data in our table. And 8 of those weeks, this poor saleswoman sold nothing. So that was not a great paycheck for that week. I didn't mention this at least one thing. The probability of at least one. There's a nice little formula where you take the probability, you do 1 minus the probability of none. That's a nice little shortcut that becomes super useful for a little bit until we get into StatCrunch to do probabilities. So how'd you all do with B? Did you just do 0.345 or 0.345 plus, let me make sure I get this right. Here's 1, here's 4, 0.069. This look like what y'all got?
Yep.
Okay. Now I'm going to suggest the way to calculate C. Instead of adding up 4, 2, 1, and 0, I'm going to do 1 minus 0.172, and I'll get the exact same answer. It might just be a little faster, a little less typing. That's the only reason to do it. Doesn't particularly matter one way or the other how you do these problems. But I get 0.828.
oh, I get it, because you just take, it's just not that one. So you just
That's it.
subtract what that already equals up to 1. We already
Yeah.
know that. So if you're only eliminating 1, that's all you have to do is, well, that's
Isn't that wonderful?
yes,
That's-
love that shortcut.
That's the only
That's what I
point
did
of
too,
this.
Peg.
Yeah, it's the only point of the not stuff, really. But this also connects to what we said back here about how do we know it's a valid probability model? Well, if it doesn't add up to 1, then all these rules of probabilities we've talked about, so if this isn't true, they don't work. So these two have to be met in order for all of this to work. Awesome. Okay, so at least one car. Note what we would be adding is all of these together. 1 car, 2 car, 3 car, 4 car. Well, that's the same thing as the complement of selling 0 cars. So D connects back to C in that it's a nice shortcut, and we can just do this one. And now we've got the probability we've sold 1 car or 2 cars or 3 cars or 4 cars. That's what this means. And that language is fun. You'll get used to it. 0.724. Awesome. I love it when you all make connections. Cool. Anyone stumped on any of this or got lost or was confused in how I wrote things or said things or I mean, let's keep going then. So this one, let's just talk through four real quick. We have to decide if these are disjoint. Before we decide, remind me, what does it mean to be disjoint? Also known as mutually exclusive. What does that mean?
They have no outcomes in common.
Okay. So if we randomly select a female student and we randomly select a junior from a high school or a college or whatever, is it possible that each of these events could have the same item in them? And the item we're considering is a junior and a female.
Yeah, that can happen.
Right. What you're asking is, could you have a female junior or could you have a junior that is female? And of course, yeah. So they're not disjoint. There's an overlap there. All right. What if we roll a die? And the first event is getting an odd number. And the second event is a number less than 4. Now, one thing that's a little, you should always assume when you see a die that we're saying 6-sided unless otherwise stated. I mean, it's not fair to expect you to assume that, but that is, I think, a pretty common assumption. So you need to think about this as a 1 through 6 outcome. Disjoint or not disjoint?
It would be not disjoint because they could get a 1.
You got it. If we look at the sample space of each of these, I'm sorry, let me try again. The sample space of odd number is 1, 3, 5. The sample space of less than 4 is 1, 2, 3, 4. So there's actually 2 overlapping outcomes in this, right? They both have a 1 and a 3 in them. So definitely not disjoint. We could modify problem 4 to make it disjoint if we took away gender and put in randomly selecting a freshman, or is it man? I don't know. And randomly selecting a junior. That's probably disjoint because you can't be both a freshman and a junior at the same time. I don't know if that's helpful. Maybe that's just worse. Okay, so let me let you try number 5 and 6. Now, if you're not familiar with the 54 cards, notice we're now putting jokers in the deck, so that adds 2 jokers to the 52 card playing deck. If you're not familiar with how many spades and hearts and all the rest, you can look at your reference sheet. I'll just do a little reminder. There are 13 spades and 13 hearts. There are 26 red cards. There are 4 aces. And not face cards, let me tell you how many face cards there are. There are 12 face cards. So for those of you that aren't familiar with that, just as a reminder, the page where we give you that information is page 265. This is all the cards. So 13, 13, 13, 13. So that's where that's coming from. Also note that this page has all the probability rules on it.
Is a joker a face card?
Great question. I have no idea.
Yes, it is.
Okay, joker's a face card. So we
Yeah,
need to
it
change
says
that.
it right on that problem. It
Oh, I
says
could've
which
read
are
it.
faces.
Oh, it does? Oh, which have faces.
Yeah.
Okay,
I'm
thanks.
so with you, Peg. I did not read it. So we need to change in this scenario, because we're including the jokers, we need to change this to 14. Okay, let me give you 5 minutes. If you finish before 5 minutes, feel free to tell me and we can talk sooner if need be. I just do this because I have a hard time not talking. Okay, that was 5 minutes. Do we feel good about what we're talking about?
Yeah, I think so.
Okay. What'd y'all get for A?
5/9.
So agreed. I don't
Okay.
disagree.
Oh,
I
do you
guess
want me to not reduce?
Oh, no, that's no. What I was thinking is there any overlap between Starbucks, Caribou Coffee, or Crazy Mocha coffees?
Okay, hang on a minute. Am I in the right place? Oh, okay. Find the probability.
553. Yeah. No, I agree that Starbucks,
Oh.
there's 5 of these and 2 of those, and there's 9 total, so 5 out of 9. The thing we need to think about is, are these disjoint outcomes? And I don't actually know. Do you all know? Is Caribou Coffee a chain?
Yes, I don't know
Okay.
Crazy Mocha.
I don't either. But I guess we can assume that they are chains. Go ahead.
I'd say they're disjoint because you're not going to be in a Starbucks and be in a Caribou at the same time.
That's what I'm thinking we are to assume. And this goes back to the first discussion we had, I think, on the first day of class. It's contextualized knowledge, right?
Right.
Taylor, what it would separate.
How did you get 5 for Starbucks? It was
'cause
3
that's supposed to be a
Starbucks.
3.
Okay.
Thank you.
And I meant by that is I put like 3/9 and then 2/9.
Got you. Yes. If we were to write out step by step, like in symbolic notation, which I think is maybe important, is we would say this or Caribou Coffee, which is the probability of Starbucks plus the probability of Caribou Coffee. Because they are disjoint, we would say 3/9 plus 2/9, which is 5/9. Good. To me, the challenging part is making sure we get that things are disjoint. And that's where sometimes the context might not be 100% clear, but I don't know, it should be. I think the ones we give you, definitely in the exam, are quite clear. All right, so what's the probability it's not Starbucks?
2/3.
You got it. 2 out of 9 plus 4 out of 9. What I'm doing is taking the 2 Caribou, the 4 Crazy Mocha coffees, and we get 6 out of 9, which if we divide 6 by 3 and 9 by 3, we get 2/3. Either one of these answers is fully correct. I don't particularly care if you simplify the fractions or not. Excellent. Okay, so note the common thread between question 1 through 6. Let me try again, 1 through 5. They are all disjoint. So all we had to do was add up the individual probabilities or add up how many options there were for each of these disjoint. That's not going to happen down here. All right, so what did you say for A?
I
Okay,
put 13/28.
Well, we have to use the 54.
I said
Sure.
13/54.
I got 26/54 and reduced it to 13/27.
So let's check that. I'm sure you're right, Peg.
Well, yeah,
I want to show. Go ahead.
what I did, when you say the card is a spade or a heart. Wait a minute.
Are there spade hearts?
No.
Good, they're
That is a
disjoint.
spade
So-
or a heart. Okay.
Right.
And there's
It's either
13
one or
of
the
each.
other.
That's how I did it. I'm like, how did my brain work 5 minutes ago?
Good. Yeah, right. Yeah. I'm with you.
Yes, 13 and 13 is 26. Over the whole deck, including the jokers, is 54. And then I just reduced it by dividing them both by 2 and got 13/27.
Excellent. Now, for those of you who maybe don't enjoy reducing fractions, note I typed that fraction in Desmos. And then this little fraction button on the left will get us our simplified fraction. I am not testing your ability to simplify fractions. That is not important to me. I think there are instructors who believe that's a necessary skill. And while I maybe respectfully disagree, I also think it's fine that they ask students to know how to do that. I'm not interested in that because you can do it in Desmos. So for me, I would accept either the 26/54 or the 13/27. Now, Laura, I think you said 13/28. That would be a problem for me if that's what you had. So make sure if you do simplify things that you do have it correct. I mean, it'd be like a half point or something, but still. Okay, what do y'all think? Does that seem okay?
Sure.
Now, let's take a look at red and ace. First question, are they disjoint?
No.
Right. So the second question is, how many red aces are there?
My answer's wrong.
Nice.
I
Okay.
double counted.
That's it. That is why we have to keep track of this piece right here, this probability of E and F. So let me write out what this looks like. So the probability of getting a red card is 26 out of 54. Jokers are colorless, I believe, right? It looks like this has both colors on it.
I think
The
they're-
probability of ace is 4 out of 54. And then I don't think we answered my question. How many red aces are there?
2.
You got it. So we have to subtract that double counted, right? We counted the 2 red aces here, and we also counted them here. And to get a correct count, we can only count them once. So we subtract the 2 extras. If you remember how fractions work, all you do is the top and the bottom stays the same. So this is kind of what it looks like. You just add together what we call the numerators. This really becomes 28/54. Now you can also just type this whole mess in Desmos and not even worry about anything. 26 divided by 54 plus 4 divided by 54 minus 2 divided by 54. And if you're required to give a fraction because it said so, click the fraction button. 14 out of 27 is your answer if you want it simplified. Okay, LaShawn, that's where I don't know. Do we all agree that Joker is a red card?
Oh, I don't know. Are they really going to go out of their way and make it
Oh.
so tricky?
You know what, Peg, we did it again. Look at what this
It
says.
says that there's 1 red and 1 black.
Oh my
So
gosh.
that's not a tricky, that's just a we didn't read issue.
And on my notes, up at the very top in the boldest Sharpie that I could write, I said, slow down and read the problem.
Add
Oh,
an expletive to that and maybe it'll help you remember.
there's 3 of them.
Okay, good. All right, so it turns out that it is not a nice, neat, there's not anything we can simplify. It's 29 out of 54. Thank you, LaShawn, for helping us read. Yes, I think I am demonstrating what not to do. I've done it before, right? What to do, read the problem first before you do it. Yikes, okay.
Oh, that's okay. The other day, Cindy thought there was 13 queens in a deck.
Oh,
So
That was nice.
I know.
that's good. That's where, again, going back to context, anyone who is a gambler or a card player or whatever has an advantage in this section when it comes to these problems because you know this. And anyone who never's played this stuff, you have a disadvantage because you don't know the context as well, which is, I don't know. So
To be fair, I was thinking hearts, not queens.
okay, how about face cards? What did we decide? Jokers are face cards, and kings and queens and jacks are face cards. So that's 14 face cards. Now, did you all use this trick? The word not is 1 minus the thing. So if we do 14/54, that's how many face cards there are. Subtract that from 1, and we get the number of non-face cards. Now, everyone hates me when I do this, but 1 is the same thing as 54/54. And so that's one way we could do this without a calculator.
They
But
will
also-
make, Eric, they will make you do it that way in the night class. They love it.
Okay, all right.
So just to let you know,
I will pretend not to do it and see if they do it.
they're gonna like, what? No.
I'm happy, those of us, like if you're close to my age, what am I, like 39? We were taught this, right? And 39 and above, like this was the thing you did in elementary school, right? I think. Even in college, my professors were like, do this all by hand.
You guys, you found my joy. I love
Rick.
fractions.
Okay.
I
Hey,
could-
you're weird.
I
Everyone
know, I'm
hates
so
fractions.
weird. I love fractions more than anything else. I think they are so cool. Yes, I am weird.
I'm on that page 2, Peg. I love fractions too.
Yay.
Okay, excellent. Did anyone have any questions on what we just did? Because we're about to do a slightly more complicated worksheet, but the exact same concepts. So if we were to note, by the way, the concepts we looked at, you just got tested on, can you tell if things are disjoint? And you needed that to do these calculations, which meant, did you use just this piece of the formula, or did you also have to use this piece? You also use this as a shortcut, not particularly necessary. But helpful, right? And then the one thing I didn't write down, which maybe we should add, is the probability of at least one is equal to 1 minus the probability of none. We're gonna expand that a little bit in 5.3. So we're gonna come back to that. But those are the concepts we've just done. If we counted them, 1, 2, 3, 4 concepts. So
Okay. Can I
talk to me.
just quick ask a question?
Yeah.
So because you have never said it, but 1 minus the probability of none is always going to be, 1 minus 0 is 1. Okay, forget it. I answered my own question. I was going to say 0, but it's not.
But this doesn't mean 0. It means if we're saying at least one black card, let's say, is in the deck, then
Okay.
we calculate the probability that we didn't get a black card. So it's like that.
The little C.
Yes, it's
Okay.
like this problem right here that we did. So this is what we mean. Now, in this case, it did actually mean 0 cards sold, but it doesn't matter whether the outcome is a 0 or not. It's just if we
Okay.
want at least one thing out of a bunch of different options, this is a little shortcut.
Oh, I'm glad I asked. Okay,
Yeah,
thanks.
I'm glad you asked too. Good. Okay, so let's try it. How about I give you 5 minutes for this whole, well, let's just do this whole first page. 5 minutes on this. See if you can do the whole first page in 5 minutes. It looks very similar, right? But I'm going to do this too. I'm going to read the problem before I answer it.
I don't know if anybody else is, but I think I'm ready. Hopefully I'm right.
I'm ready.
I'm ready.
Okay, let's do it then. Would you all say for A? That was 2 out of 8, but
Not disjointed.
Not disjoint.
right. It's possible. Maybe it's rare, but it's possible that a mother could be a Democrat. Yeah. Good. I had a student once on this question. They wrote like, why are we talking about this expletive in this class right here? And I was like, oh, I guess seems like you don't like Democrats or something. Yeah, fun. Okay, what about this one? Drives versus bicycles.
I put not disjoint because I mean, it's possible someone really could. It might be rare, but someone could be that dedicated Democrat to go and make sure they get their poll in on their bicycle.
Well, the point is not that the Democrat is You're cracking me up. Those Dems on their bikes, yikes. The point is not that they're getting to the polling station. The point is, did they ride their bike? Can they ride their bike, or can they drive their car at the same time? And maybe, Laura, what you're saying is their car is a bicycle. So that it's like the Fred Flintstone car.
Very much so. So that one's disjoint.
The only way I could think that these wouldn't be disjoint is if they rode a bus and had a stationary bike on it. I don't know. I don't know how I think the idea is that you can't drive a car and ride a bicycle at the same time, although we could probably argue that you could. Good. Okay. I'm going to read this so I don't screw up like I did in the last 5 problems. Here's our probability experiment. We're doing this thing. We have a random fruit flavor added to the water. The spinner to the right is used to determine the flavor. The dotted lines show equal sections. Okay, so really what we're thinking here is there's 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. What did you say for A? Are they equally likely?
I said no.
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 Good, because it didn't say are the spaces equally likely. They said are the outcomes equally likely. Good.
But then when it asked to explain, I just put what the probabilities were for each individual flavor, but are you supposed to so that's good? Okay, good.
That works. Yep. You could
Okay.
also say grape has the most outcomes, or you know,
Yeah,
like they
you know
don't-
the class in the words. So I was like, if we don't have to write a sentence, that's really cool.
Yes, you don't. If you can explain it with numbers, that's happy. I'm happy with that. You know, numbers are words too. Oh, sorry. There's that timer. Okay, good. So we're saying no. Not equal amount of sections, maybe not equal. What did they? How do we label this? Not equal sections for each flavor. I don't know, whatever, or state their probabilities. Okay, what is the probability to get peach?
1 out of 8.
Nailed it. Feels good, right? How about grape or peach? Oh, I wrote it backwards. Did you get 4 out of 8 on that one?
Yeah,
Good, because there's 3 grape, 1 peach. All right.
yeah.
What's the probability that it's not grape? Oh, did we know grape? We didn't. Probability not grape. So this is where
8. I did the 8/8 minus 3/8 is 5/8.
And here's why in this case I'm like, the complement rule, whatever. I could just count that there's 5 not grapes and just write 5 out of 8. Or we could do what you said, Laura, 8 out of 8 minus grape was what, 3 out of 8, which equals 5 out of 8. When it's this small or this simplistic of an experiment, it, you know, the complement isn't that much of a time saver. In fact, it probably took longer to write all this than it did to just count up to 5. But whatever. Awesome. How are we feeling? We're feeling this is not chapter 4, right? That's good.
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 That
Don't
was
be
my
dis-
thought exactly, not chapter
good. Don't
4.
be discouraged if chapter 4 is still not 100%, right? It's a difficult section. It's heavy algebra. There's not a lot of contextual or like real life usefulness in it for what most of us do in our lives. For me, it's what I did in my master's degree. I use that a lot, although way more complicated. But give yourself some grace and just keep tasting it and practice with your reference sheet. That's your key. Okay. Anyone have these numbers already?
I do.
Oh, tell us them, will you?
Yeah. Okay, so for the male total, you've got 60,518. For the female, 61455. And then private all the way across, I'll start at the top, 83867. 9524. 1909. 26673.
Thank you, thank you, thank you. That saves
Welcome.
everyone a lot of time. Okay,
bet.
so let's do 5 minutes and you all run wild with this. Remember, your key is, are we looking at disjoint? Let me highlight a few things. We did a poll of this many people. They were this aged, and we asked them, what is your health insurance status? Meaning, what kind of health insurance do you have? We looked at them by gender and insurance coverage, and you are to assume gender is disjoint, number one, which is probably a pretty easy assumption. And then the one that's maybe not as easy is assume each of these are disjoint. I don't know that that's true. I know that there are people that have like supplemental insurance. If you can afford it, you might have both private and Medicaid, but assume that each insurance type is disjoint, so that there's no overlap between those four as you're answering these. All right, 5 minutes, and then if you get done early, let me know. Okay, did you all say you were ready? Because I was totally gone.
I got 2 left.
Oh, carry on. Oh, let me do like 2 minutes. More time, or should we talk?
I'm good.
Okay. So we already talked about the disjointness between the genders and the insurance types. Note we are selecting a person at random, meaning, as we know from the English language, right? A means one. In 5.3, we might select 3 people and then calculate the probability that something happens. That gets a little more complicated. That's coming, so get ready for it. Actually, don't get ready for it. Just focus on this and then know we're gonna add to it. And then finally, we're asking that you give these to 4 decimal places. All right, so when you did probability a person is male, did you do 60,518? So 60,518 over 121,973.
Yes.
Yes.
Nice. And that comes out to 0.4962.
Yep.
Excellent. That's the most straightforward calculate. Well, it's one of the more straightforward calculations here. C is another of the very straightforward. We just want to know how many uninsured people are there. 26,673. How many total people were in our survey? 121,973. What kind of probability calculations are we doing here? Classical, empirical, or subjective?
Empirical?
How'd you know empirical?
Because we're dealing with data.
You got it. That's the key. Yep. This is a data set. From this, we're going to use it to predict maybe the types of insurance that Americans have, age 15 to 44. Good. Okay. Everyone happy so far with the first 2? So I'm going to give you a trick. Note, not uninsured is a double negative. Does that mean they're insured? Yeah, actually, it does. What we're meaning then is we're thinking of these three categories, but we already calculated the uninsured, and not just means complement. So if I do 1 minus 0.218, well, okay, if I could write properly, I've got this. You could also add up all the other ones if you wanted to, get the same answer. It doesn't particularly matter. I get 0.7813. How's that for everyone?
Yep.
Yep.
Okay. Good. So B and C, straightforward, just how many of these are there, divide by the total. D, a little more complicated. We could use a complement to do it, or also we'd have to think about adding up the other three. Now, E is the first one where we have to pause and ask ourselves, are these things disjoint? So we're looking at private insurance or Medicaid. In other words, we're looking at this one. Oh, okay, well, or the other one, but I can't highlight it. So we're looking at Medicaid versus private. Those look disjoint to me. In fact, I told you they were disjoint. We have to assume it that way. So it's the sum of these two totals divided by 121,973. 83,867 over 121. Now, whether you write these separately or add the two numbers together and then divide by 121,973 doesn't particularly matter. 9524. Anyone got any of these right or wrong?
Yeah.
Yeah.
Yes.
Good.
Yeah.
I will say on this portion of the exam, this is often what the midterm looks like.
I got this one too.
Good. This is what the question looks like. This is often what we give. Those of you going into medical fields, this is a very common type of thing. The nursing department specifically has said, please make sure you look at these two-way tables.
Mm.
This is a common thing you're going to see in research articles that you're reading about the effects of a drug on different people. Probably the drug would be administered, and then they'd have a gender and race and all the rest. So it's a thing that's important for you to be able to read in the nursing program. Will you actually need it on the floor? Yeah, probably not. But when you do your research, maybe. Okay, so how about male versus male and? Now this, we just threw this one in here, and we haven't done any practice of this. What does it mean to be male and private insurance? What has to be true?
There is something, they have common outcomes.
In fact, it has to be those two things at the same time.
Right.
So this is the
Oh, that.
answer to male and private. Does that make sense? The overlap. Yes. If you think about the Venn diagram, what we're doing here is we're looking at this piece here. So this was male, this was private. We want only those respondents that were both male and had private insurance. If we were talking about male or private insurance, this is the probability we would be subtracting because it would be the one that we had counted twice. So let's see, 41,209. This is the trickiest one on the page, I think. Does everyone feel happy about that?
Yeah, that's what I got. But I do remember when I was doing it, that it was really tricky for me. And I had to keep going back and rereading and looking at it and going,
This is the first question where we have asked you to directly calculate the and probability. We're going to do it a bit more in 5.3 if I'm remembering correctly. But in the previous worksheet, we didn't do any of these calculations except, where's the one where we had an overlap? Except this one right here. This is the and probability. If we were to write that one out, this would have been the probability of red and ace. We didn't think about it like as calculating probability per se. The way I talked about it was how many aces are also red. And we said, oh, it's 2. And then I just wrote that without really explaining that we were calculating the probability of a red and ace card occurring. That's the not disjoint pieces. So that's what this one was. If, by the way, if these two things had been disjoint, this answer would have been 0. Okay, now this G is the most complicated question on here. The reason is, are these two events disjoint? And the answer is no. Well, I'll just say it. So let's go up here. And what we're calculating is female, which is this. Oh, it's not going to let us do that, is it? Let's see. See if I can make this happen. Oh, come on. It's this one. And then private insurance is this one. So if I use the totals, I got 6145 for female, 61,455. It's the total females that took the survey. If I take the private insurance, that's the 83,867. If this was Canada, then this category would have been 0, right? Because they don't really have private insurance there. It's all government. But then if you look at what I highlighted, do you see where the blue and the yellow overlap? I'll do it in red. This right here is what we just counted twice. This is why we've got to subtract that 42,658 from the total, because this is the number of females that have private insurance. It's the and probability. So we got to subtract 42,658 over 121,973. How we doing, y'all?
I got this one wrong and I know why.
Good that you know why. Not that you got it wrong. Anyone else confused? This is a very confusing one. I often need to take more time to explain it. So please, if you're like, what?
I'm celebrating over here. Compared to chapter 4, I got this down. I am
Nice.
happy.
Nice, good, celebrate that. Fail. They're 8417. Laura, I want to ask this, if this is too personal question, don't answer it. I'm wondering if we compared how you functioned in chapter 5 versus chapter 4, did you have more time this week than the last 2 weeks?
No, about the same.
Man, I was so hopeful that you had more time. And then I could be like, see, it's not that you can't get it. It's just that you had more time to devote. Okay. So it's just that you understand this better. That's great.
Yeah, the algebra is horrible for me, but I can do fractions all day long.
Me too. I spent hours and hours and hours on chapter 4 and chapter 5. It's like I can do 3 worksheets in like 45 minutes.
Love it.
Yeah.
Same for me, Peg. You go,
Yeah.
girl.
I know, right?
Well, one of the things, if we were to compare what you have to do, how much data did you enter into StatCrunch on this one, right? Like 0. And that's a good minute or 2 or 5 minutes, depending upon your typing skills for chapter 4. Okay, anyone have any questions on any of this? I know we've got 2 votes of confidence, but if you are a person that's sitting over there thinking, I did not get this, I feel terrible, please don't think that, number 1. And number 2, please ask a question so we can help you. Otherwise, let's go on and see how you do with number 4. This is a little wonky. It's getting really into the weeds of talking or the language. Let me set it up, actually. Let's talk it through. So a commuter passes through 2 traffic lights. All of the previous problems, we've just been doing one thing. This thing, we come up to a traffic light, drive through it, come up to another one, drive through it. So we know when we hit a traffic light, there are 3 options that could happen. So traffic light 1, I'm going to draw a little tree. It could be red. That's the one we don't want. It could be yellow. That's where we hit the gas. Or it could be green. Just kidding. You're supposed to brake at yellow. And that's where you're still hitting the gas. Well, then off of each of these, that's the first light. The second light, we could encounter another red light. That's where you're cursing because you're late and you want your child to be at school on time. And that 1 extra minute will make the difference. But what are you going to do? I guess cause an accident. And then if it's green, wonderful. That's what you hope for because you're behind. You've got food down their throats and in their bellies. Wonderful. But now we got to get there. And then yellow, I missed that. So that should also be 3 here, but I don't have space. So if I'm to draw the 9 outcomes, I could use this. And one of those outcomes coming off the top here is hitting 2 red lights. That's where you're like, the gods must be angry. It's all against me. I don't know that lights are random. Aren't they all kind of on a timer or do they have sensors? I don't really know. So that's one outcome.
Can
Go
I
ahead.
just back you up for just a half a
Yeah.
second? Because I think I just figured out what was wrong with every time I was trying to make one of those trees. So when you go to the second branch, you always include the first branches, like you go RR. I went R. I had to walk away from this worksheet because I could only get 6 outcomes. Because it never dawned on me to continue the RRYY Greek GG.
You were starting another tree, right? Branches have to be connected to the trunk. Otherwise you have a new tree. Yeah, good. That's a
That
really
was
good.
tripping me up. That's
Good.
it. I'm not caring. Okay. Oh my gosh.
And
I don't
what
know
you
how
said-
someone can do this course without listening to you guys. Hey.
Well, what you said before was a good point, if I can remember what it was. Wait, I had it, now I lost it. Oh, and the tree diagramming didn't seem to be like a super important essential thing. And that is true, because the whole point of this is only to be able to create the 9 outcomes. If you could write out all the 9 outcomes from this, who needs a tree diagram, right? You got it.
That's how I finally had to do it.
Nice.
That's
And
when
that's
I
totally
finally
fine.
got it. When I just,
Good. Okay, so that's the setup. For A, you are doing the sample space. You need 9 outcomes. Let's connect that to the multiplication rule. Light 1, 3 possible outcomes. Light 2, 3 possible outcomes. The multiplication rule says multiply the possible outcomes for each little piece and you get the total outcomes in the sample space. That's where we got the 9. We're told to use R, Y, and G for the abbreviations. Great. Do that sample space. Then list the outcomes for the events as they are defined here. So read that carefully. There's 3 of them. And then you're going to talk about disjoint for these events. And then you're going to do some computations. So let me give you 5 minutes to struggle with this. This is one that students often struggle because it's all words. Okay, how we doing? What sweets? Anyone need more time, or are we ready to go through it?
I think I'm okay.
Okay. I'm just gonna list these and assume you all had them. The order I'm listing them doesn't matter. I'm following my tree diagram up here if you're interested in how I'm generating it. So red, 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 yellow, red, green. Let's see, yellow, red, yellow, 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 green, and then green, red, green, yellow, green, green. So these are the 9 possible things that can happen when you encounter 2 stoplights on your drive to wherever. So event B says, all right, what is it that they're the same color? So they just have to have the same letter. So note we're picking this one, and this one from the sample space, and those are the possible outcomes in event B. Y'all feel good about that?
Yeah.
By the way, it's nice that the labeling of the event matches the labeling of the number. I don't know that that was intended. I think it was. Okay, so event C is that the colors are different. Well, that happens to be everything that's not the same color, right? So it's all the other ones we didn't underline. It's a little more annoying to write out, but RY, RG, YR, and I'm just pulling them right from here. These are the not same color ones. YG, GR, GY. Okay. We all feel good about that.
So I have a question, Eric.
Please.
Do we count like the RG and the GR? Do we count both of them? That's where I kind of got stuck wondering.
Great question. For now, we're going to treat them as different things because if you think about the order they happened, that makes them different. So first we hit a red light, then we hit a yellow light, which is different in terms of your driving experience than hitting a yellow light first and a red light second.
So is it always gonna matter like the order? Because
No.
I think we had a question one time where it was like if it just happened, so it's
Right.
not gonna always matter the order. Okay, got it.
Doesn't that make you super excited? It means you're
Oh
gonna
yeah,
have to
it
pay
really does.
really close attention to what it says. Yes. Yes. Now it's in chapter 6. We're going to ignore the order and we're just going to look at things like one way we could change this is how many red lights did we hit? 0, 1, or 2. And there we don't care about the order. It's just, did we hit a red light or not? That's a way to take this qualitative information and turn it quantitative. But that's for chapter 6. So that's really where we're going to look at the order mattering, although in 5.3 it also matters a little bit as well. But that's because those probabilities are looking at sequences specifically. Okay, good question. All right, at least one green means we're picking out all the items in here that have a G in it. So here's a green, and then the last 3 here all have greens. So again, like Reagan said, doesn't matter the order here. Even though it's like the one that's even worse is like flipping a coin or rolling a die twice. And then you're like, does that order really matter? Can you even tell the difference? Okay, so we got all of our sample spaces defined. We got our sample space defined for the experiment, and then we got 3 events outcomes defined. So first, is this list of outcomes disjoint from this list? Because this is list B, this is list C, and this is list D. So what'd you all say for E? Yes, they're disjoint, or no, they're not disjoint.
So what'd y'all say for E? Or do you all not know? We need to talk about it.
I get confused on the ones that are using a sample space.
Okay, so first let's start with the definition. Disjoint means no common outcomes, nothing that's the same. So when we look at the two defined sample spaces here, well, the two list of outcomes for event B and C, do we see anything that's the same?
No.
So it's disjoint.
disjoint.
Good. Yes. Why? There's no common outcomes. So if you ever need to explain why something is what it is, write down the definition. Are they disjoint? Yes. What's the definition of disjoint? No common outcomes. That's how you explain it being disjoint. Now, when we get to C and D, all right, are there common outcomes between C and D? Let's see.
Yeah,
Yeah, let's see if we can circle
so
that.
that one's not disjoint.
Good. So GY and GY are the same in each of these. GR and GR. Oh boy, sounds like we got a mud bath going on outside. YG fail. Oh, wait, no, YG is the same in each of these, right? YG and YG and RG and RG. There you are. Those are the same. So we're going to say no. And if we're being specific, we would say that RG, YG, GR, and GY are common outcomes. You don't have to say exactly that, but that's the most specific answer. How's everyone doing?
Doing all right. Keep
Okay,
going.
okay, keep going. So what's the probability of B? What's the probability this happens?
3/9.
You got it. There's 3 outcomes in event B. There's 9 total outcomes. So there you have it. Those of you that prefer simplified fractions, there you go, 1/3. Okay, what about B or C? First pause. What did we say about B and C? Are they disjoint or not?
Yes.
They're disjoint. Good. So all we have to do is add together the probability of B. There were 3 outcomes in B. Let's see, 1, 2, 3, 4, 5, 6 outcomes in C. So we just add those two together. Probability of B is 3 out of 9, plus the probability of C is 6 out of 9. So the answer is 9 out of 9. Is that a valid probability?
I don't know.
Can a probability be equal to 1 is the question.
Yes.
Yeah. Yep. That can happen. If you think about what this says, event B is that you hit the same lights. Event C is that you hit 2 different lights. So the question is, what's the probability when you go through 2 lights that you hit the same light or a different light? Well, that's the only thing that can happen, right? They're either both the same color or they're a different color. Those are all the possibilities. So B or C together represents the entire sample space. I think it's always important for you to pause and look at your answer and say, is that a possible answer? Lots of times students think this one's wrong because they're like, how could it be 1? Don't worry, 1 is a certain event. All right, how about C or D? I'm going to just ignore something to see if we can't get it wrong. 1, 2, 3, 4, 5. There's 5 events in D, 6 events in C. So let's see, 6 out of 9 plus 5 out of 9 equals 11 out of 9. Is that what you all got?
No, I did 6 out of 9 plus 3 out of 9 equals 9 out of 9. Minus 2 out of 9 equals 7/9 because I overlapped.
Okay, good. I did this
Where
on
am I?
purpose. Yeah, Peg, that's perfect. I did it like this on purpose because I wanted you to see this. I've seen this answer on this very worksheet a lot. Is this a possible probability? Can 11 out of 9 happen?
No, it's over 1.
It's over 1. So we know it's wrong. We know we did something wrong. And Peg, you're 100% right. What did I just do?
I don't know, but you were freaking me out because I'm like, oh no, what did I do wrong?
You didn't do anything wrong. So I did it a little differently than you did, which is yours way is fine. I said there's 6 outcomes in C, there's 5 outcomes in D. If we add those two together, we would get the OR part, but we have to subtract how many are the same. Well, I already counted that up right here. RG, YG, GR, GY. Those are in both of them. So I have to subtract that extra 4, those 4 that we counted twice, in order for this to make any sense. And that gets us to 7 9ths. Now, I like what you did. I think you did it a little differently. Some people, one way you could do this is you could start with C and say there's 6 outcomes in C. Are there how many unique outcomes are there in D? Well, there's only this one unique one. So there's 6 plus 1 more new option for a total of 7 options for this OR probability. I don't know if that's helpful.
I did it the long way because just for me to remind myself to not double count.
Nice, good.
Yeah.
Yes.
So some of the stuff when I do on my worksheet, I just do it because that's how my head is making me remember stuff.
That's perfect. That's the way to do it, as long as it's correct, which it was. Does anyone have any thoughts or concerns about all this? Questions or? I will warn you that my stat lab is quite challenging from what I recall from previous classes. One of the critiques that students often make about stat lab is that the language is a little bit different. And I don't know that that's, I think it's more the context for this set that can get tricky. But if you find yourself spending a ton of time in stat lab, don't, after an hour, stop and bring it to class and we'll look at a question together. I think it's really good practice to help put this further in your brains, but please don't spend 5 hours trying to get one assignment done. I would love for it. We can do it together if need be.
That was chapter 4. I would literally sit down and at like 8 o'clock in the morning and do work until 11, do our meeting from 11 to 1 and then work until 3. That was chapter 4 for me. So I am like celebrating this. Chapter
Good.
5.
Celebrate it. Celebrate it.
I am.
I'm having trouble getting through chapter 4 on my stat lab still.
So I don't have time to pull it up now because I have to go to my next class, but maybe on Wednesday, some of the ones that you're stuck on, we could do together. In my in-person class, we do worksheets and stat lab and the rest. And that group finds it quite helpful for us to look together, because often the things that mistake students are making on is the decimals, which doesn't have a whole lot to do with the content. It's just being the accuracy thing. And sometimes it's a little bit of the language. They also tend to be more complicated problems. The other one is making sure you know the shortcuts that are built into my stat lab. For example, you should not be typing anything. You can open everything in StatCrunch automatically, and there's very little data entry required for StatCrunch. Whereas with these worksheets, any data set I give you, you have to type in.
Yeah, but where do you find all that stuff?
The little bars. I've got 2 minutes. Let's see if I can show one.
The little bars in StatCrunch? I mean, I'm typing in every.
You
I'm
should be
done with it.
typing nothing from your My Stat Lab because it's
'Cause
all
I
there.
was-
Let me show you real quick. I'll show you one thing and you'll
Okay.
hopefully forever see it.
All right, I will.
And there are some in chapter 5 where the data sets are there for you. So let's see, let's just find, I'm pretty sure 4.3 has some data sets in it. No, that one's nothing. So here's the table. So click the
Right.
icon to view the table. You click that, and then
Okay.
this little thing, open in StatCrunch. And you'll see that little thing throughout the problems where there are data sets that you need to do calculations with.
Joe, I just hit the floor.
Okay, I wish I
Oh.
would have said this sooner. Yes, anywhere in here. So here's another table
Oh.
that in the corner, open in StatCrunch.
Oh, my word.
Eric, I do
Hours.
believe you have told one of the classes before. You have
I
shown
may
it.
have.
So
Oh, you
maybe it
probably-
might have been a
I've seen that in the evening class.
Yeah,
That was the
I
evening
think it
class.
was in the
Sorry,
evening
morning class.
Oh, I'm sure I just missed it,
That's
obviously.
fair. It'll happen. But you just need to, yes, that, so
Oh. Okay, thank you.
take advantage of that. You're gonna need that further on. So I'm glad we caught it like halfway through instead of,
Yeah, because I didn't know how, I mean, I imagined that I would be taking the exam from like 3 o'clock in the afternoon till midnight.
no. And what I'm gonna do on the exam is any table like this, I'm gonna have it pre-typed. And what you will do is what we've been doing for the projects. You will go to data sets, and I will in the midterm prompt for that particular problem, I'll say search for midterm number 3 or whatever it is, and it'll pop up here and you'll just click it, because I don't want you to have to spend any time typing. And then if I make a mistake, it's on me, not on you in the typing. So yes, I don't want the typing to be in the way.
Awesome.
Okay, I gotta go.
But you guys, I'm
Thank
one
you.
of the 10 seconds. I'm making a new assignment sheet. I will send it out 5 minutes.
Oh, and to
Okay.
that point, Peg, I really appreciate your comment at the beginning. I need you all to share your frustration with me. It's a
Yeah.
strong motivator.
Yeah.
It's to get me to get my act in gear. I did go through this class and I cleaned up the assignments other than that one worksheet. This one, I didn't remove it yet. I don't think I can from here.
That
can I?
one is one they turn in.
Okay, I gotta be careful because I'm
It was
about
the
to put-
5.1 worksheet 1, which did get removed, but I think, Peg, it might have been after you might have already done it, but it did get removed.
I
I turned everything in, I want to say yesterday, day before yesterday, I don't know. It's okay, but I was just gonna say to Cindy, you're sending out the assignment sheet, and I'm like, oh my God, I don't even know if I want to look at it.
Oh, no.
When I look at it and then I look at the screen, nothing matches and it makes me insane.
It should match this week because I just went in and looked at them and everything should match.
Awesome.
And that, everyone, you need to understand that is 100% on me. What Cindy sends is accurate. What's on the screen is all me.
Oh yeah,
So,
I totally blamed you.
good.
Okay, we need to let Eric get to his class, so he
Bye,
can
guys.
Let me get to class. All right, y'all. Have a great day. Maybe we'll see you on Wednesday or tonight.